Hello, guests and reviews. I'm from Wuhan Textile University. My name is Chen Kewen, and I'm very pleased to present our research paper to you today. The title of our papers is Agreement Design Retention-Based Virtual Train-on Network. This page also introduces our other researches. First, let me give some preliminaries to our research, which focus on aspects related to virtual dress fitting. Virtual train-on technology has been a hot research concept and is widely used in e-commerce, games, argument-related, and other fields. In recent years, with the continuous development of deep neural network, deep learning-based virtual train-on technology has triggered more and more research and attention in applications. Virtual train-on technology allows customers to quickly view the results of training on different clothes styles in a short period of time, achieve efficient garment selection. However, the current virtual train-on methods are not effective in manipulating the structure of clothing design, and do a lot around the training on clothes to experience the real feeling of training on clothing. Then we start the related research. We conduct experiments on the dataset that is used in CPV10. This large amount of data is enough for us to conduct relevance in deep studies. Then, let's take a look at what research programs have been made so far on virtual fitting, starting with the virtual fitting paper from CPR 2018, which proposed a two-stage approach that first used a shape context matching algorithm to generate warp garments, and then use the ULITE generate to learn image senses. To improve this model, CPV10 proposed a Nanable convolutional geometry matching network and Nanable transape deformation, learning the GAM fabric with the target person. It achieved reasonable train-on image senses. However, the detail of garment dealing with large transformation situations are mostly blurred, and the texture of the clothes tend to produce excessive deformation. ACGPN adaptively generates or returns different body parts in the synthesized image based on the predicted semantic layout, and learns the generalization ability of complementation, though the training process of occlusion regeneration to solve the problem of poor generation of complex pairs, as well as lay bypass methods. In order to solve this problem of maintaining the virtual train-on effect of garment design structure, the study proposed a new garment design rotation-based virtual train-on network. The aim is to achieve a virtual train-on that is closer to real train-on for the user. The main contributions are as follows: a multi-stage spatial distortion module combining peaks transformation and clothing structure deformation factor is proposed as a way to obtain realistic clothes design structure and accurate train-on alignment. A symmetry segmentation module is introduced to help hand compliance, pause, and occlusion, generating mask for body parts with a mask for well-dressed ear. A counter training network combined with a synthetic network of U-light network is proposed to perceive the detail of clothes and body parts. There are three parts here. The first part is what we propose, a multi-stage space warp generation module. The main purpose of the module is to distort the target garment C to the corresponding ear of the reference person, to deform it natural according to the human pose, and to present the maintain the characteristic of the garment. Among the established methods, the sensible spline transform is a model used to spline transform two images to be aligned, which computes a two-dimensional interpolation of several pairs of control points in the two images, so that the control point of the two images can coincide actually. However, simple training of the spatial transformation network and the application of singing able simple cannot ensure accurate maintenance of the design structure of the garment. From the results of CP return, the final out of the deformed garment always appear to be overshaped, and their situation was found to be related to the overtrain on of the predicts TPS Preliminaries. Therefore, we define a differential constructor tend to smooth and the ear of the excessive deformation according to the actual mass, and use the differential mass to the construct the irregular deformation to distort the garment. Design structure reasonable. The second part is the Symmetry Segmentation part. Symmetry Segmentation prediction is the estimation of key parts of a person and the morphology of the clothing. The module aims to separate the body parts and synthesize the image of body parts and the clothing intersection else. Some provisions must fit round body type Preliminaries directly into the network, leading to confusion between clothing picture and the skin picture. To solve this problem, a similar segmentation prediction measure is introduced to predict the symmetry segmentation graph MP of the people who have trained it on. The third part, main goal of the adversarial training synthesis module is to synthesize a visual train-on image while presenting the complete details. Establish must view the output of the clothing distortion module in the standard U-like network structure, resulting in the loss of the clothing and other details. If the web clothing is copied directly onto the target person image, unnatural seams appear. A sameness image is obtained by blend the web clothing and the try-on paper's image with the synthesis mask. The study purpose improve network structure of unit which has two different encoder and one decoder. Encoder 1 actually factor from the other no target details of the human body, and encoder 2 actually factors from the predict symmetry segmentation graph MP and the web garment CW. The figure extracted by the two encoder and then concatenated and sent to the decoder. The decoder filters the extractor factor to obtain the call try-on image CF. Then the finally try-on image is output by GAN network and L-GAN host. So some of the contributions we made are based on the mature structure preparation space network SPGN, which combines the picture transformation of the clothing design structure and the deformation characteristic of the clothing structure proposed in this study. The clothing can be deformed and warped more occasionally while maintaining the clothing design structure. A webbed discriminator is implemented to improve the stability of the synthetic model. Two modules are proposed: a multi-stage space web generation module and a adversarial training synthesis module, not only in air occlusion and clothing details generation. There is fitting fabric on the aspect while maintaining the structure of the original clothing design. This page introduces our quality results. In this paper, we use a paired dataset collected by Han et al. The same dataset used in Wheaton and CP Wheaton method. The purpose method is also visualized and combined with the CP Wheaton and ACGPN. GR Wheaton combines picture conformations with the garment structure deformation picture to produce web garments that are accurate, clean, and rose design structure is maintained, as shown in the first and third rows of the left columns of Figure 6. The corner structure is unreasonably well in the try-on image of other components merged. In the first, third, fourth, and fifth rows of the light colors, the studies merged generates the complete garment structure, but the results of the other maps have irregular deformation of the garment design structure. The FFIM, IS, and FID score of CP Wheaton, ACGPN, and all GR Wheaton. For FID, lower score better. For SSIM and IS, higher scored better. Quantitative show that GR Wheaton outperformed other maps. Okay, that's all. Thank you for your attention.